Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 21st. Taking a look at significant wave heights for the North Pacific Ocean, we see the start of an active pattern. A storm developing northwest of Hawaii, producing 41-foot seas aimed well at the islands and scheduled to make a push towards the U.S. west coast, with yet a second system developing off the Kuril Islands, forecast to build even stronger and also push towards the Hawaiian Islands. Much swell is on the way. Let's start this week's tour by looking at the jet stream. Jet stream level winds help support storm formation. When storms form, help direct their path. What we're looking for is a dip in the jet, and we certainly see that. We see a good consolidated flow pushing off Japan, ridging west of the date line, then falling into what's called a trough. That dip in the jet here, that helps support counterclockwise flow aloft and at the surface, and is what helps to support storm formation. And of course, storms generate wind, wind generates seas, seas as they radiate away from the fetch area turn into swell, and of course generate surf when they hit your beach. All right, good trough here with 190 knot winds pushing into it, setting up a great environment to support storm formation, and we already know that a storm is developing there northwest of Hawaii. Also notice consolidated jet making it to just off the California coast, was about 133 west or so. The thought is if this jet can hold together, push into the coast, and not split like it currently is just right here off the coast, that will usher in a wetter pattern for, of course, California. But, of course, that would also create poor winds and not great conditions for surfing when the swell arrives. Anyway, move this out here. We see the trough continuing to build into Sunday night, and sort of starting to pinch off a little bit here north of the Hawaiian Islands, still holding together, and then sort of basically falls apart, too pinched off to do anything. Also notice the jet is split off the U.S. west coast. That'll support high pressure here, but also notice wind starting to redevelop here off Japan come Monday, and continuing to build and feed yet another trough in the western Gulf of Alaska in Wednesday, Thursday time frame. 190 knot winds again pushing over the date line, falling into that trough, which has its apex just north of Hawaii, while a split flow continues to keep calm winds and good weather conditions over the U.S. west coast. Roll this out some more. More of the same continues into Friday. The jet, if anything, is looking more consolidated and stronger come the weekend, Friday night into Saturday, and just continues to look very solid into later in the weekend with yet another trough. Now this broader, not as deep, not as pinched off into Sunday. That is a week out with yet 200 knot winds feeding it. And again, the jet still not coming on shore. Also note that the active phase of the MJO should be in control, but again, over more in the West Pacific. It won't be till later as the MJO starts moving east that one would expect this split in the jet to actually start moving onshore into California, if it does it at all. So at least from a jet stream perspective, things are looking very good. Let's go take a look down at the surface. So here we are Sunday morning, surface level pressure, surface level winds, 50 knot winds developing here in the western quadrant of the system, aimed reasonably well at the Hawaiian Islands. High pressure between that and another developing system off the Kuril Islands, and then a broad, stormy, but not necessarily productive gale pattern, not even quite a gale really, in the northern Gulf of Alaska. We'll roll this out. The storm peaks out north of Hawaii about midday Sunday. That was midday Sunday, with winds in the 60 knot range, aimed well at the Hawaiian Islands. Fetch just barely coming, what is that? A couple 100 miles north of the Hawaiian Islands, and actually starting to brush the islands by late Sunday evening. Next system starts developing here off of Japan, or the Kuril Islands, 55 knot winds. Also notice 55 to almost 60 knot winds still in the system north of the Hawaiian Islands. Now this one, the first one, I guess this would be storm number 10, I believe, starts making a push towards the U.S. west coast. 45 knot winds in its southern quadrant, aimed well at the U.S. west coast, and it starts lifting north and fading some while 50-knot winds push over or approach the date line, aimed well again at the Hawaiian Islands. So two systems in play here. We'll just go into Tuesday. The first system starts fading out. Second system, storm number 11, still with 55-knot winds pushing towards Hawaii, but not going as far south as the previous system. Lighter wind pattern looks likely for the Hawaiian Islands for this system, and then it fades out, and yet system number 3 starts developing on Thursday, looking a little bit not as cohesive. And again, remember, the trough isn't as well formed here, so it's more of a broader fetch area on Friday. Multiple centers of a main circulation here, about 35-40 knot winds. Additional stuff rotating under it, or fetch rotating under it. A broad fetch of 35 to 40 knot winds comes Sunday, and then yet another system starts developing off Japan. So a very active pattern indeed. Let's go down to see to the surface, see what effect these winds have on the ocean surface. So here we go, using the 18Z version of the model. For the North Pacific, we see 41-foot seas there. It says 42 here, but actually 41 northwest of Hawaii. We'll just sort of click through this here, try to find the peak somewhere right around in there. 47-foot seas. Yeah, 47-foot seas right there. Take a look at that, aimed a little bit east of the Hawaiian Islands. And then the system, the interesting part here, it starts swinging towards the U.S. West Coast Sunday night with seas in the, what was that, about 44-foot range, maybe in Southern California, that sort of an area, and then pushing a little bit more north towards Northern California into Monday morning, 42-foot seas, and then starts to dissipate, but still good solid 32-foot seas, moving pretty close to the California coast, even by Monday night. While our next system here, let's roll this back, we kind of missed that. Here it starts forming on Monday, falling on a pretty good path towards the Hawaiian Islands there, and quickly blooming with 48-foot seas projected, continuing over the dateline Tuesday morning into later Tuesday morning, still 48-foot seas, and then moderating as it gets closer to the Hawaiian Islands, not quite hitting the islands. We did some closer analysis on this one too, and these readings are well on the Great Circle paths. We'll take a look at that in a second. Anyway, swinging just past north of Hawaii, and then dissipating. Now, relative to the U.S. West Coast, still good fetch here. It looks like it's aimed a bit south, but still a good amount of fetch towards California. Swell should result as well. Then we go into this sort of a more fragmented type pattern on Friday night. Again, look at that, 33-foot seas over a small area aimed at the U.S. West Coast, and that sort of fades out. And another fragmented bits behind that, but all this means is steady swell, not as big as the two swells number 10 and swells number 11, assuming all this goes as expected, but just a continuous, rather turbulent ocean state, much swell resulting if the models are correct. Let's do a quick look here. Here's storm number 10 just developing. We want to look at, and these are the Great Circle paths relative to Hawaii. This system sort of pushing a little bit east of the Great Circle paths, a good amount of energy, supposedly working its way south to Hawaii. We got burned a little bit on that last eddy call. Everyone did by believing the equations the model had in there in regard to how much energy and when that energy would move into Oahu. This system, again, because it's so close, one would expect that would not be as much of an issue, but maybe not as much size is going to result as what the models might suggest, just because of the less direct track into the Hawaiian Islands. Now here comes the next system. Now watch this. We're looking for right there. Watch this energy and watch it relative to this path. And it actually falls pretty well down the 319 to about the 333 degree path. And we'll do that again there just so you can see it right there, there, and there. And that suggests to us that a good amount of energy will result for the Hawaiian Islands from this system. Now let's take this all back. play the same little game relative to, we'll say, Northern California. Here we go, storm number 10. Now watch this. This guy, energy is passing well south of the Great Circle paths there, but then when you get to about Monday morning, the storm sort of makes this east to northeast jog, or at least the prime seas do, and look at that, pushing right up the Great Circle paths into Northern California and also Southern California as well. And now let's go back and take a look at this next system here. Again, storm number 11. It's falling a little bit south of the Great Circle paths. That's the 296-degree path there, but not horribly bad. I mean, most of that energy looks like it's first at Hawaii and then sort of swinging up somewhere in here. Kind of hard to tell. We'll see what happens. The expectation is that not as much size is going to reach into Northern California as one would expect, but maybe down in this area it could do pretty well indeed. Let's look a little bit further out in time and see what we can expect. First off, winds in the Kelvin wave generation area. Here it is right here, roughly north of New Guinea, out to about the date line, 3 degrees north and south of the equator. If you want to be liberal, up to 5 degrees north and south of the equator. What we see is trades, easterly winds in the northern section of the Kelvin wave generation area. Westerly winds in the southern, well, not even the full southern, because that's pretty much north winds there. Just in this one small patch here, what is that, about 16 to 20 knot west winds there. Not particularly what we'd call a large area of westerly anomalies. Looking back the past 5 days, here's the Kelvin wave generation area, basically from here to about here. We see this westerly wind pattern again in the southern part of the Kelvin wave generation area, and not at all in the northern portion of it, and just barely in the southern portion. That's through the 19th. So the past 5 days, this pattern has held, attributable to low pressure in the Tahiti and west of that area. All this attributable to the building active phase of the MJO moving into the Kelvin wave generation area. Now, yet one other view, this is from the TAA buoy array, actual buoys down at the ocean surface, not modeled, not satellite, anything. And clearly we see easterly winds in the northern half of the Kelvin wave generation area and somewhat in the south. But here again is that little bit of westerly winds. They're actually pretty strong, but they're very far, just barely about at 5 south and barely in the Kelvin wave generation area. This is anomalies, differences in normal for this time of the year. You see, even though the trades are blowing very strong, that's normal for this time of year, so really no difference from normal. But in the southern Kelvin wave generation area, for sure, the westerly winds that are there are strong compared to normal, but again, over a small area. So the talk is, why do we talk about westerly winds here? Well, two things. The first being, if it was earlier in the year and there were a lot of warm water over where the westerly winds are, we'd say that would help to support formation of a Kelvin wave. And a Kelvin wave is a pocket of warmer than normal water that is generated in this area. It actually, the westerly winds take surface warm water, push it to depth down about 150 meters, and it travels the whole way across the under the equator, across the Pacific, and then erupts at the surface near the Galapagos Islands. But there is no expectation that will happen because, one, these westerly winds really aren't strong. They're strong, but they're over a very small area. It's got to be very confined to just right around the equator, and these are pretty much far south. And the bigger issue is there just isn't a whole lot of warm water there, because a whole 5 other Kelvin waves have pushed through this year alone already and basically scooped all the warm water that was here and transported it out over to the Galapagos, and we'll tell you the rest of the story in a minute. And here's yet one more way to look at the wind pattern in the Kelvin wave generation area, basically. So this is the whole planet on one chart. The Kelvin wave the date line is right here. And so just a couple of degrees either side of that. And we're looking for reds and yellows. Those are westerly anomalies, but they're very small, limited pockets. Here is the current batch of westerly winds that are going on. That is definitely bordering on a westerly wind burst, and the forecast for the next week suggests even stronger westerly anomalies. But the issue really is there's just not a whole lot of warm water there. So you can have all the west winds you want, but if you don't have warm water to push to the east, you're probably not going to get a Kelvin wave. And just real quick here, we'll take a look at the GFS model and see what the actual wind forecast is. Again, here we are. Here's our little patch of westerly winds today at Sunday. We just roll this out, and you can see those westerly winds persist, and actually it looks like a little bit more start building into Tuesday, but not very strong, and it's there, but it's weak, and it's trying to get going. The neat thing about this is also notice that the easterly winds up here start fading and moving further north, and we just have this big area of calm winds here. Now, what we'd almost be looking for this time of year, if we were in a coming out of a strong El Nino, you'd expect to see trades starting to rage here, but we don't see that even in late February, which is a little bit interesting. We're not going to get too excited about anything just yet. And we also see westerly winds again trying to hold on even a week out. Not strong, but a little bit. But again, the issue is there's not any warm water here to push to the east, so it doesn't make any difference. So the westerly winds that are in play, again, here's that area, the Kelvin wave generation area right here, or notice this patch of blue here. That is the active phase of the MJO. Okay, this is outgoing long wave radiation model. We've been through this before, but we'll go through it real quick. Again, what this suggests, blue suggests, is less sunlight reflectivity off the ocean surface, meaning there's more clouds here, and that means the active phase of the MJO. This over here suggests more sunlight reflectivity off the ocean surface, high pressure, and therefore the inactive phase of the MJO. The 2-week forecast per this statistic model is that the active phase of the MJO starts easing east and fading, while the inactive phase of the MJO starts moving into the West Pacific. The dynamic model is a little bit more favorable from our perspective in that the active phase is basically supposed to hold steady for the next 2 weeks, with the inactive phase holding steady. We would honestly expect the typical active phase sort of hanging in any one region of the planet is typically about a 3-week sort of event, and we're just now getting into that event. So this seems a little bit more like the likely outcome rather than the statistic model. And yet, here's another way to look at this. The ECMF model. Again, imagine you're at the top of the planet looking down on the North Pole, and then as we go around the chart, we're going from the maritime continent, let's say Indonesia, over the dateline, into the West Pacific, over towards the Americas, into the Atlantic Ocean and Africa, and then towards the Indian Ocean. And this chart follows the active phase of the MJO. These are like the 12th of February, 14th of February. The current position, and the further away from the center you are, the stronger the active phase is. So this model suggests that currently we are in the West Pacific. The active phase is actually supposed to get stronger the next couple of days, and then weaken some and crash somewhere as it moves over the Americas. The dynamic model here, the GEFS model, suggests if anything the active phase is again supposed to get strong, maybe a little bit stronger than this model, but not move east and crash basically somewhere, maybe south of Hawaii or so. So this outcome is a little bit more what we're hoping to see. That would keep the active phase over the Kelvin wave generation area, and though it will not create a Kelvin wave, what it does do is support the jet stream there in the dateline region, and that's what you really want to have to create a good strong storms pushing over the dateline into the western Gulf of Alaska. Now this model, having the active phase move closer towards the U.S. West Coast would then eventually usher in rain in the U.S. West Coast if it happened like this, and if it was a little bit stronger more out here, that'd be better. Where this does not support, or at least at this indication, does not clearly support a lot of precipitation for the U.S. West Coast. And then finally, the CFS model. Now this is past history down here, October, working our way towards February this year. The reds and the yellows are westerly wind bursts associated with the active phase of the MJO. This was the the 5th active phase of the MJO that created Kelvin wave number 5. We went through an inactive phase here, and now we're coming out of it, moving into yet another active phase of the MJO over the dateline. The dateline's right here. Westerly winds, these oranges and yellows suggest westerly wind anomalies, just like what we've seen in the other models. Starting pretty much right about now, February 26th, let's say, and holding solid into about the middle of March or so, and then weakening as yet another inactive phase. These dotted lines suggest the inactive phase of the MJO, and then really pretty much a weak MJO pattern forecast after that. So this is probably the last big hurrah for this El Nino in terms of solid, a good push of the jet stream to produce storm development and then maybe precipitation. California would be right about here. This window right here would be the window when the active phase would push south of California, and therefore best opportunity for precipitation. What would that be, about March 7th through the 20th, roughly, just eyeballing it. So something to look forward to. And then after that, the inactive phase takes over, and we're into the April-ish time frame. And it seems like the precipitation window would pretty much not be very well supported for this other projected active phase of the MJ. Also notice there's not a whole lot of westerly winds associated with it, and we're just late in the season in general. Next, we'll take a look at subsurface water temperatures. Again, West Pacific here, East Pacific here. Good amount of warm water here. 29-degree water temperatures they were here to about 140. They're already starting to retreat, and this is the expectation as El Nino fades. Warm water will start more building back over here normal and less warm water over here. This is actual water temperatures. It is anomalies, differences from normal for this time of year that we're really looking for. And again, there's warm water here, but it's not anomalously warm. And if you have west winds here, well, there's not a whole lot to push off to the east. This is Kelvin wave number 5 here. It's fading already without having done hardly anything in terms of producing any impact. A little bit of 4, maybe 5 degree anomalies here just west of the Galapagos Islands. Also notice this cool water starting to make an incursion into the East Pacific. We've been watching this line here, and it's just been steadily moving east, even irrespective of westerly wind bursts and things that are going on. This is the demise of El Nino here. At some point, this warm water is going to gurgle up to the surface, get carried off by trades. Cool water is going to come in, and then we'll fall into at least a neutral pattern, if not a weak, some flavor of a La Nina pattern. Here's the different version, but basically the same picture. West Pacific here, East Pacific here. Here's the cool water coming in. Here's Kelvin wave number 5. It looks a little bit warmer in this image with 5 to 6 degree anomalies there. A little pocket of cool water here off the right around the Galapagos Ecuador area. This is actually the upwelling phase of Kelvin wave number 4. So as soon as that moves out, we expect this guy to start erupting somewhere here west of the Galapagos. Warm up, try to rewarm the surface waters here where El Nino is quickly fading out. That is Kelvin wave number 4, and the warm water associated with it is in steep decline already. We'll see that in a second. But basically, this is the last hurrah for El Nino. Here is upper ocean, upper 300-meter ocean heat anomalies, and of course, here was Kelvin wave number 1 in the March-April timeframe, number 2 in the May-June timeframe of 2015, number 3 in the fall of 2015. Very strong, robust Kelvin wave number 4 in the late fall, early winter timeframe. And now here's Kelvin wave number 5. You can see it here, sort of pales in comparison to these, more in line with Kelvin waves number 1 and 2, but it is already starting to lose some of its heat. Here's the upwelling phase of Kelvin wave number 4. Typically you go through a Kelvin wave, then you have a little bit of a cool down before the next one rolls in. So that's kind of where we're at there, and this one is not particularly robust. So we've talked about westerly winds that take what would be anomalously warm water here in the West Pacific. Notice it's not warm. It's actually kind of cool here. Take that warm water, push it east in the form of a Kelvin wave. That Kelvin wave would erupt somewhere in this area. Trades would take it and push that warm water off here. And clearly we see a definite El Nino signal. But notice, not a lot of warmth here. Typically, you want to see it really slamming into Ecuador, the Galapagos, and then getting carried off to the west. Instead, what's happened, this entire El Nino is not a lot of warming's happened here. It mostly erupts right around in here somewhere west of the Galapagos, and then has been advecting, moving off to the west into the Nino 3.4 region, which is bound between about 120 and 170, 5 degrees north and south of the equator. That is the traditional area for monitoring El Nino, and temperatures have been quite warm in this area, but the reality is the footprint needs to be larger than just the area that's monitored to have the desired atmospheric effect, especially to pull moisture into California. This El Nino has been westward displaced. All this warm water has been westward displaced, not so much over here like the 97 or the 82 super El Ninos. We believe because of the westward displacement, the jet has kind of been, it's been strong out in here, but not so much moving into the U.S. West Coast because it doesn't have the warm water down here to help sort of drag it along. And so all the activity has been out in this region. Good for swell production, not so great for precipitation. And the net result has also been the jet stream's been a hair bit further north than one would expect. You'd actually expect it to come further south and push more storm and swell energy into Southern California. And that's not really been the case. The focus has been mainly been from Point Conception northward, or even further north of that. But it has been active, certainly, for Northern California. We'll take a quick zoom-in look here. We're not going to go into all the details, but you can clearly see there is a bit of warm water here starting to show up along Peru that wasn't there, and patches here. But again, you'd expect to see all these reds well built up in this area, and it never was and hasn't been for months and months. And the other part here is most of the warm water has been out here between about 120 and 160, and even that is in steep decline now in terms of the 2.25 degree anomalies or more. They're rapidly fading. That is, the east winds are taking this warm water that did gurgle up somewhere around in this area, pushing it off to the west, but since there's no other Kelvin wave below and really not a lot of warm water, this is all just starting to fade out. So we are in the demise of El Nino. And just one more view. Again, you can see here's where all the warm water is, westward displaced. Not a whole lot going on here. A little bit of buildup here along Peru, but that's about it. Not a lot happening in the Nino 1.2 region. And here's a quick look at the temperature profile over the past few months in Nino 1.2. We can see a steady decline. Even it was up, 2.5 degrees at one point there in November and early December. Nothing really super eye-catching, and steadily working its way towards normal. The Nino 3.4 region here was peaking out in the 3 to almost 3+ degree range, which is very warm. I mean, comparable to what was going on in the 97 and the 82, 83 El Ninos, and then has been on a slow decline, but not really. It kind of popped up again here in January, another little peak here in February, and it's still above 2 degrees above normal. El Nino threshold is 0.5 degree, so from a pure Nino 3.4 region, which is the main region NOAA uses for tracking El Nino, we're clearly in a strong El Nino pattern still to this date. Even though we're sitting here talking about the warm water decreasing and the Kelvin wave of number 5 not looking particularly impressive, we're sort of poo-pooing the fact that the reality is we are still well above normal. And so this suggests to us, and we have this active phase of the MJO going on, so there's much support for storm development. But we do believe that these temps are going to start falling here pretty soon, because we see from the satellite imagery that the volume and the surface coverage of warm waters is definitely on the decrease now, and that's not unexpected. We're actually doing pretty well considering how relatively late in the season it is. Now we've talked about westerly wind bursts, we've talked about Kelvin waves, we've talked about warm surface water off of the Galapagos and in the Nino regions, and we've talked about the inactive and active phase of the MJO, and we said the active phase of the MJO is just now starting to get a good hold on the dateline region, so we can see that clearly in this data. This is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you have the active phase of the MJO, these numbers, the daily numbers, start going negative. Very negative indeed, minus 40.2 here on the 17th of February. And still holding there. So this is a good, solid active phase of the MJO. That is starting to drive the 30-day running average negative, minus 11.42. And also the 90-day running average, minus 14.51. We want to see this guy down around minus 18 if we're in a super strong El Nino. We're actually pretty late in the season to see anything like that. But still, we expect this to go much more negative. And this guy would probably drop off a bit more too. So all in all, the active phase is having a good effect and helping to fuel El Niños still to this date. Here is the 30-day Southern Oscillation Index put in perspective going back to January 2014. This is the first false start of our El Nino in 2014. Kind of muddled along. Then we got into January 2015. You can see the Southern Oscillation Index dove well into the fall. Kind of went through an active phase thing and then an inactive phase and then an active phase, driving it down into late January. We've been in the inactive phase and we're just now starting to work on our decline for the next and probably the last good active phase of this El Nino. The expectation is at some point we're going to start seeing this Southern Oscillation Index start creeping up more towards zero, but that would probably not be until, maybe the fall of this year or so. So we got a good long ways to go. So again, the Southern Oscillation Index is driven by pressure over Darwin, this area here, and typically you want to see high pressure over here, and Tahiti, which is roughly right about here. You want to see low pressure here. Clearly we see low pressure. Just looking at the model real quick to get a sense of what's going on. We see low pressure continuing in the area of Tahiti right around here through the next, we'll just keep going here and take a look. It seems to be holding, if not forecast to build to about Sunday of next week. So the Southern Oscillation Index should continue to fall, and that would be expected along with the, as the active phase of the MJO slowly starts working its way off to the east. And what we're trying to do here is see how well El Nino is coupled with the atmosphere. So the Southern Oscillation Index suggests it's pretty well coupled. It's kind of interesting that, in fact, we have the MJO present at all during El Nino, because typically, at least as the theory goes, that's not the case, but we've seen it clearly there pretty much the whole way through this El Nino. In fact, the MJO is what's been driving all the westerly wind bursts. Anyway, so there's another index called the ESPI, does the same thing as the Southern Oscillation Index, but what it's measuring is precipitation coverage between the area north of Darwin and then this area, which is basically the Nino 3.4 region, only a little bit bigger. And what you want to see is a drier pattern here, wetter pattern here, to be expected because there would be warmer water right in here, and that would support evaporation and therefore cloud production and precipitation. Okay, current index 1.19. More positive, the better. At this point in El Nino, it's kind of amazing that we even have a positive number at all. Typically, late phase in El Nino, this starts crashing. It's actually been doing pretty good. It was up in the about 1.4 range a couple weeks ago, slowly fading, but not much, doing quite well. And you can look actually here at the rainfall anomalies. You see a well-defined precipitation band right in this area, right where you'd expect it to be. And up here you see a drier than normal pattern. So this suggests that El Nino is pretty well coupled with the atmosphere. And then finally, let's talk about one other long-term pattern. Okay, this is not related to the current El Nino directly, and it does not so much support it. Well, a little bit. But anyway, it's called the Pacific Decadal Oscillation. It runs in an active and inactive state, but pretty much goes in 20 to 30 year cycles. So since the end of the 97-98 El Nino, we've been in, I'll call it the inactive phase of the PDO. This is the active phase here. Notice cool water working its way in, warm water buildup along the coast. This is the exact same pattern that we had for 30 years building up to the massive El Nino of 97-98. All of a sudden, that pattern looks like it's starting to build in, and you can see it here. And so here you go. Here's that cool water finger. Here's the warm water buildup. Now, some of this, of course, we have El Nino going on, so it's not unnormal to see warm water along here. And as you get later in the later in the winter, you get more storms coming here. They start churning up the ocean surface. Water temperatures drop. So you can't go walk away and say, oh, clearly we're in the active phase of the PDO now, because we've been in the inactive phase for 15 plus 18 years now. Okay, and what happens is in that inactive phase, you don't have as many storms. You don't have as much precipitation. Everything that you sort of see that's been going on, especially the last 4 or 5 years, suggests that clearly we're in the inactive phase of the PDO. And I'm using these terms rather loosely and not completely correctly. But the thought is, let's just go take a look at the data here. Here is the PDO index, okay? We get that centered there, and you can just go year by year, and when you see all these negative numbers, and here is the 97-98 El Nino, and we see these positives 2.7, 2.3, 2.8, etc. And then all of a sudden, we got out of the end of that strong El Nino. We went into this long run of just negative numbers, and we had a little bit of a resurgence in the early 2000s, and then we fell back into this hole of negative numbers, and it's just been going on and on and on to 2013. And then all of a sudden we got in 2014, we started seeing positive numbers showing up again. And then when you see a 2.51, you go, wow, that kind of gets your attention, because if you scan all this data here, and we'll go back years, you're not going to find a positive 2.5 very often. In fact, not very often indeed. And then all of a sudden we get into this year's El Nino and it just goes bump it on, keeps going in the 1.5, almost 2 there. And here we are, January, still at 1.53. Now, if you go back here to the 97 El Nino, but sort of look back prior to that, there was nothing but positive numbers from somewhere around 77. Yeah, there's little bits of negatives, but a lot of positive numbers. Here's 87, there's a 2, 2.83, etc., etc. You sort of start picking through these numbers, and you see almost 20 plus years of positive numbers. Then we fall into the negative hole, and that went for about 15 plus years, and all of a sudden we're getting the sense that maybe, in fact, we are starting to dig out of that hole, and not all hope is lost here, that maybe this El Nino is just the thing we need to kick us over into the active phase of the PDO pattern. And what that would mean is that for the next 15 years, the atmosphere would be favorably biased towards El Nino. It'd be favorably biased towards a jet stream pattern that would support storm development and maybe precipitation into California. The point being, maybe this little bit of dryness that we're in here, though it's been going on for 4 or 5 years pretty bad, is the turning point. Just like the 97-98 El Nino, things were just nuts, and then it got so extreme that it flipped over and went into the, sort of the inactive phase. Maybe we're deep in the inactive phase, getting ready to flip back over to the positive phase. Don't know. We need a couple of years more of data here, but something to consider. Regardless, for now, we are in a strong El Nino, and we are in an active phase of the MJO during a strong El Nino. Series of storms stacking up on the dateline, working their way, focusing towards Hawaii with much, not even sideband, but less direct energy towards the U.S. West Coast. And the pattern looks like it's going to go for at least a couple of weeks. Fingers crossed, make the most of this. Large swell, it looks like, is on the way for many big wave locations. On top of that, our El Nino pattern is supposed to hold for a bit longer, but it looks like we're starting to work down towards the end of it. So make the most of this while you can. And besides that, we're going to be working our way into spring, and that is typically when you'd expect to see some of this pattern start to fade out. So not unusual. And so the big question is precipitation for California. Unknown, but if it's going to happen, the thought is it'll happen by somewhere around the end of February into early part of March as the active phase of the MJO starts working its south of California. So fingers crossed on that. But that's the forecast, looking pretty good right now. Make the most of it. We'll do this again next week. Same time, same channel. Thanks for watching.